Our sensor for circadian clock is a chronobiology tracker for circadian diagnostics. About 50 to 70 million adults are affected by chronic sleep wakefulness. Having an absent or dysregulated circadian rhythm can have metabolic implications, could lead to increased risk of diabetes, cause cardiac functioning impairment, and lead to neurological complications. The current technology does not accurately map the internal biological rhythms. It is susceptible to human error, leading to inaccurate reporting. And also, it's expensive and complex. Thus, there is a need for tracking chronobiology in a non-invasive manner. This could help improve clinical diagnostics and provide self-management of sleep-wake cycle, leading to personalization of pharmacotherapy for these circadian disorders. So the objectives of this project is to design a sensing platform that is sensitive for circadian relevant biomarkers, that is cortisol and DHEA, and test this platform for the sensitivity in a non-invasive biofluid, that is sweat. The goal is to design a label-free sensor with a fast response time that works with low analyte volumes. From the materials and methods, it can be observed that this sensing platform uses a nanoporous substrate and serpentine gold electrodes. These serpentine gold electrodes add another layer of mechanical flexibility that makes it ideal for on-body wearable applications. The principle of detection is that these gold electrodes are functionalized with a capture probe or antibody that is highly specific to the target biomarker, that is cortisol or DHEA in this case. We use the principle of non-Faraday EIS-based sensing to capture the sensitivity of the platform to the amount of biomarker present in the system. Whenever there is binding between the antibody and the target biomarker, there are certain capacitive modulations. EIS captures these capacitive modulations and maps it as sensor response against the concentration. From the results, you can observe that through the OCP, the sensing system is stable. Through the calibrated dose response curves, you can see that the sensing system is able to distinguish between the low, normal, and elevated levels of the biomarkers, cortisol and DHA in human sweat with good sensitivity. The black dotted line highlights the signal to noise threshold, and you can see that it is minimal and that noise does not affect the overall sensing response. We also tested this platform for sensitivity on human subjects. Through this infographic, you can see the experimental design, where we have a period of rest for hours 1 and 2, followed by a period of spike, which is caused by onset of physical stress or exercise, and followed by a period of rest, which is at hours 4. Through the sweat cortisol levels extracted from SLOCK, you can see that it is able to significantly distinguish between the pre-spike rest levels and the post-spike rest levels. This was also correlated with salivary cortisol levels through ELISA. And this is because salivary ELISA is one of the gold standards for tracking the levels of cortisol for diagnosis of circadian disorders. And as you can see, it is significantly higher for spike levels than the rest levels. Finally, we tested if the sensing response is highly specific to the biomarker that we are trying to detect. And you can see from these results that it is sensitively able to distinguish between the non-specific and the specific molecule, and that there is minimal cross-reactivity between cortisol and DHEA. So to conclude, SLOCK is a sensitive platform for tracking the chronobiology through these biomarkers, cortisol and DHEA. It has a limit of detection of 0.1 nanograms per ml, and it operates over a dynamic range of 1 to 500 nanograms for cortisol and 1 to 200 nanograms per ml for DHEA. And this is highly relevant to the physiological range of these biomarkers in sweat. It has a fast response time that is less than 15 minutes, which making it rapid, and it uses low analyte volumes as low as 10 microliters. Thus, This SLOCK sensor is a robust, non-invasive way of self-monitoring your chronobiology and it helps with tracking circadian disorders.